qRT-PCR is widely used to measure RNA expression. For example, in siRNA knockdown treatment, we use it to quantify how the treatment affects target genes. The workflow, starting from cell treatments, such as siRNA, transfect, or drug treatment. The cells are harvested with trizol, and total RNA is extracted for cDNA synthesis using RT-PCR. Finally, RNA levels are measured by qPCR. To ensure high-quality qRT-PCR analysis, you need to know the critical steps that have important impact on the final readout. Now, let me walk through the most important tips during this process. First, RNA quality starts with healthy cells. It's important to keep the control and treated groups in a similar condition. For example, if siRNA knockdown kills the cells, you need to optimize the siRNA concentration and treatment time to minimize the dead cells compromising RNA quality. Besides, before lysis, you should wash away floating dead cells with PBS 2 to 3 times. At the trizol lysis step, use enough trizol to make sure efficient lysis. A good starting ratio is 1 million cells per 1 milliliter of trizol. At the RNA extraction step, after adding chloroform, mix the sample thoroughly by handshaking or vortex. I recommend vortex for 10 seconds. This step is critical as sufficient mix ensure RNA recovery. At phase separation after centrifuging, carefully collect only the clear upper aqueous layer. Avoid touching the interphase, which may carry DNA and protein contaminants. For reverse transcription, select primers based on your experiment. Use oligo-DT primers, random hexamers, or a combination of both. To choose right RT primers, you need to know whether the RNA of interest has poly-A tail. If you are unsure, using a combination of oligo-DT and random hexamers. Finally, for qPCR, it's important to confirm primer specificity using the melting curve. A single sharp peak indicates clean amplification and reliable qPCR data. These are the tips based on my experience. If you have other insight, please put in the comment.